Welcome to Ask and Learn.
So in this problem, we have a block pushing down on two springs, which means that the springs will launch this block up into the air. So we want to find the maximum height, h, we'll call it h2, that the block will reach. Well, we're given the weight of the block, just 30 pounds, and the weight is actually mass times gravity, and we're given the k's for each spring, so kb, 200 pounds per inch, and we'll see 100 pounds per inch. Now, since we're dealing with springs, we know that there's going to be some sort of potential energy once it's being pushed down, and we know that since the block reaches a certain height, that means it has a certain potential energy at that height as well. And since there's also movement as it reaches that height, there's kinetic energy. So you have kinetic energy, potential energy of the spring, and due to the height, which means that we can use conservation of energy, so which is just the initial energy equals the final energy of this event. So we have initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy. Well, when the block is pushed down on the springs, it's not moving anywhere, so its kinetic energy initial is 0. And when it reaches a maximum height, we can say at that instant it's not moving as well, so its final kinetic energy is 0. So we're left with the initial potential energy. So if we say that when the block is pushed down, that will be our initial height, h0, so it means that there's no potential energy. So the only potential energy is from the spring. So you have V, potential energy of the spring, we'll call it SP1, is equal to, so the potential energy of the spring isn't accounted for because the block is being pushed up into the air. So the only potential energy is potential energy of the height. So we have V potential energy G2. So then if we look at this side, potential energy of the spring, we have V SP1 is equal to 1/2 KB x1 squared plus 1/2 KC x2 squared. So the potential energy of both springs. So now we plug in our numbers. We have 1/2 times 200 times x1, which is 4 squared. That's the length of that spring, plus 1/2 k, the stiffness of the spring, 100, times its length, which is 6 squared, 6 inches. So we have for the potential energy initial of the spring, we have 3,400 pounds per inch. So we plug this back into our equation. We have 3,400 is equal to the potential energy due to the height, so mg, which is just the weight. So we have 30 times the height, h2. This is what we're looking for, so we solve for it. So we have h2 is equal to 3,400 divided by 30. So we get, for the height, the maximum height that this block reaches is 113.3 inches.